Let's start to talk about the PCI Diag, PCI Diagnostic Tool. So PCI Diag is essentially a working sample application. What does it mean? It means that you can open it without the need to modify anything or write anything. It is a working application. You can access your device with this application if you are on Windows. You would need to install an INF. If you don't have an INF installed, you can install an INF and generate one to your device via the wizard. I will not show it here because I don't want it to be leave the main path we're talking about here, but we have videos on our website and YouTube. You can watch how to generate an INF via the wizard. So if you have an INF installed in Windows, we have the same thing in Linux where you don't need an INF. You can access your device. We will see everything you can do. Another thing PCI Diag can do is to give us an inspiration to see how we implement the device opening mechanism, the license mechanism, the interrupt handler mechanism. And because it is a working sample, it is a great tool to learn how we utilize our API and how we make things happen. Another thing that a PCI Diag tool can do for us is to be a debugging tool, a great debugging tool. How so? Because it is a working application, you can basically in WinDriver, if you're not familiar with WinDriver, you can generate your own project's code automatically. And this code will probably need to be modified to fit your needs. So if the project you created and modified is not working, what we recommend is go to PCI Diag and try to do the same thing. Once you can do that, you can see if PCI Diag is working, something is wrong with the way the code was implemented. By the way, if PCI Diag is not working, that would probably suggest that something is off between the device and the operating system. We have the samples in C, .NET, Python, Java, and PowerShell. Let's see a live demo. This is a virtual machine. You just make sure you can see it. Okay, I know it's small. Let's enlarge. Okay, so where am I? WinDriver is being installed on the local disk, right? C. WinDriver 16.3.0. We just today launched 16.4. In 2 weeks we will launch it. So today I'm going to work with 16.3. We have different folders, the wizard folder, the designated Xilinx folder, I will not get into it, and the sample folder, which we need for our demonstration. In the sample folder, you can find samples of code in different languages, Python, Visual Basic, Java, C#, and we will work with C today because it's the most common language for developing drivers. And you can see here that we don't have only a PCI Diag sample, but we also have USB Diag sample. And we have a Xilinx folder for Xilinx DMA IPs. My last webinar was about DMA and XDMA specifically. So if you're interested in DMA, look for it or send me an email and I will send you a link. Lattice, which we just launched a partnership with, Altera, and so on and so on. So we have samples for different applications and different devices. So I encourage you to explore it. So I entered samples folder, C folder, and PCI Diag. And what we can see here is this icon. Okay, I have the project here that was opened with the CMake list. A great tool I recommend working with. I will go to the build. Okay, I've already built it. We will get in the code later, but I just want to show you how easy it is to access the device. We're opening the PCI Diag, and here it is. Let's make it larger. Okay, so now all I have to do is open my device. In order to open it, I need to scan it, okay? So let's find the devices on this machine. It's a virtual machine. PCI Diag scanned all the PCI devices that are linked or connected to my computer. I can see the VPID, vendor ID, device ID, or product ID. I can see the location and the physical location of the device on my board, and other information. For example, the interrupts. I can see that this device has a level sensitive interrupt. I see it has IRQ10. I can see the addresses, the memory range. This device has 2 bars, 0 and 2, and I can see the size of the bar. I can see the base, and so on. This is not a harmful, let's say, or intrusive operation. You can open PCI Diag on your computer, scan the devices, and see this information. And now I need to select my device based on the VPID, and the device I'm choosing is this one, number 7. So I hope you can see it well. Maybe enlarge it even more. Okay, I click 7, and here I have it. I have this device open, and now I can do things. You see that the menu has changed. So I don't need to scan the PCI bus or find an open one, but now I can manage IPC. IPC is inter-process communication. We had a webinar dedicated for it, and there is a lot of materials and a dedicated webinar for it, yeah? For inter-process communication, what does it mean? It means that one application is connected to a device, and this application can send messages from the device to other applications. Very useful if you need more than one application accessing a device at the same time without creating now, access mechanism and making sure that the data is not corrupted. So I won't need to manage IPC, but I can open it, and we can see that this menu offers us to register a process, which we don't need currently. Option number 5, read and write to the PCI configuration space. Here we can find a lot of information. Okay, I clicked 5, and I am getting all this information from the registers. From the configuration space of my device. I can see the VID, the vendor ID, device ID, command, status, the offset, the size, and the operations I can do reading or writing. So here I can see a lot of information that was derived from the configuration space. I can read from an offset and write to an offset, okay? Which is great. Without coding anything. So we can perform operations with the configuration space. We can read all the configuration registers defined for the device. Right here. Let's click 3. Okay, and here I got even more information regarding what you see. I have details. It's the same list, but with additional info. So you can read and write from a named register, or scan the PCI or PCI capabilities. And this one is more relevant to our webinar or our subject, because here we can see all the capabilities our device have. So if we want to know what capabilities are there, or for example, what interrupt type do we have, and I will talk about interrupt types later. it is just written here. Okay, we didn't need to create a complicated and sophisticated mechanism to access the kernel. All we needed to do is click a few buttons, and we can see the interrupt type of our device. What is it good for? Later on, I will explain how to set the interrupt type on the interrupt handler on WinDriver. You must know the interrupt types your device is supporting, and if you're expecting one interrupt and you cannot get it, and you're getting a different type of interrupt, so this is the place to make sure that which interrupt types are supported. Maybe you would need to reconfigure the bit stream or the IP of your device. Maybe there's an issue with reading the configuration space. However, this is what the device is sending. So the information is available here for free without coding anything. Right, so we saw the different options this menu offers us. Let's even allocate a or free shared buffer. Let's do that. Why would we need to allocate a free shared buffer? Because we can create an access for other applications to access this buffer. So again, let's say I want to create a non-contiguous, which is more complicated, shared buffer. I want it to be 30,000, right? And here I have it. I got the user address, the kernel address, and this and the size, and this address is available for other processes to access and get the data. Let's free the buffer. Okay, it is freed. Okay. You can register or unregister, plug and play, and power management events. We won't get into that. Read or write memory and IO addresses, right, to the device, not to the PCI configuration space. Enable or disable the device interrupts, and allocate or free memory for DMA. So if your device is supporting DMA, you can allocate or free memory for DMA. Let's do that. I will write like 7 and 8, the reading and writing to IO addresses to the device and enable and disable the device interrupt. We will do a live demo. After I'll explain the mechanism of the interrupt handler. Let's allocate the scatter gather memory. Let's give it now 45,000, and here we have it. Okay, we have a scatter gather memory allocation for DMA purpose, just like that. We can use it or we can free it. Let's choose freeing it. DMA webinar took place 2 weeks ago. It is recorded and live on our YouTube channel. So this is the PCI Diagnostic Tool. If in any point you are having issues opening your device, the license issue, reading and writing, then something must be off with the device or the way the license was submitted. Maybe you are on the demo license, because this sample, as you can see, is working and should work on every PC with every device. And I encourage you again to try it yourself. Let's close it. Okay. And back to our demo. Sorry, slideshow. So this was the live demo of the PCI Diag Diagnostic Tool. As I said, you can find it on the sample folder.